Okay, geometry students, in this video we will be looking at the slopes of lines and parallel and perpendicular lines. And then lastly, at the end of the class period, we'll be looking at a couple of definitions, okay? Before we get into today's notes, I want to quickly talk about coordinate geometry and non-coordinate geometry. Now listen, you don't need to take notes on this, and I don't want the video to be paused while I'm speaking about these two terms, because you will not need to write this information down. You will not be tested on this information, but still, please listen well, because when I use these terms in class, coordinate geometry or non-coordinate geometry, you need to know what I'm referring to. Okay, here we go. Now, coordinate geometry, or we also call this analytical geometry, uses the coordinate system to study properties of segments, lines, planes, and other figures. Let me give you an example. Again, don't write this down, just watch, okay? I'm going to draw a very quick, crude coordinate plane. Here's my y-axis, here's my x-axis. And let's say I wanted to draw a triangle that looks something like this. There we go. And I'm not sure what to call this. Here's a vertex, here's a vertex, and here's a vertex. We're going to say this point is over 1 and up 1, so this point's 1 comma 1, and we'll say this point's over 1, 2, 3, 4, and up about 5, so we'll call this point 4 comma 5, and then this point over here we'll say it's about 8 comma 2. Okay, now none of this needs to be written down, just listen to me talk. Okay, and what if I asked you to find the area of this triangle? Okay, well, first of all, you'd have to find the height, which you could do, and then you would have to find excuse me, you would then have to find the length of this line right here, the base, and so on and so forth. But understand something, you would be using ordered pairs, and notice also that this triangle is drawn on the coordinate plane, on your XY axes. Okay, so whenever a figure is drawn on the coordinate plane and you use the coordinate plane as you study this figure, that's called coordinate geometry, which makes total sense because this is called a coordinate plane. And it's that simple. Coordinate geometry is when you have figures, shapes, segments, lines, and planes drawn on the coordinate plane, and you study them on the coordinate plane. Non-coordinate geometry, or Euclidean geometry, is the study of the properties of segments, lines, planes, and figures without using the coordinate plane. Now here's an example. If I had that same triangle drawn like this, and then I told you the height was 3, and I told you the length going across was 7, and I said find the area of that triangle. Well, first of all, this triangle is not drawn on the coordinate plane. Here's your coordinate plane over here. It is not drawn on the coordinate plane. Number two, I'm not using ordered pairs or coordinates to study this problem. Okay, so this would be an example here of non-coordinate geometry. And you might say, well, Mr. Earhart, which one of these two geometries are we going to study this year? Both. There are going to be times that we're going to look at figures on the coordinate plane and use ordered pairs to help us. There will be times we will look at figures not on the coordinate plane and we will study them that way. So we're going to use both of these, and I wanted you to at least be introduced to the difference between these two types of geometry, okay? And you will not be tested on that, but I wanted you to know that. Okay, let's take some notes. Copy this heading in your notes if you would, please write this down. Let me pause right now and tell you my philosophy of videos, okay? My philosophy is you can never speed a video up if the teacher's going too slow or if he or she's being boring. However, you can pause it if I'm going too fast. So I go fast on purpose, and I expect students to raise their hands and ask the supervising teacher to pause the video when it needs to be paused. So I am going to go fast, okay? All right, your heading today is, write this down, slopes and parallel perpendicular lines. Slopes and parallel perpendicular lines. The lesson number is 1.5. Okay, lesson number is 1.5, and if you would please include today's date right here so your notes are organized. Okay, include today's notes. Here we go. First of all, we need to start off by reviewing the two ways to find the slope of a line. And you should have learned this in Algebra 1 and Algebra 2, so I am going to go pretty fast, okay? I'd like you to copy this line in your notes, so please take a second, draw a coordinate plane, and I want you to put an ordered pair that's over 2 and up 3, in case you can't see that, over 2 and up 3, and then an ordered pair that's over 1 to the left, so negative 1 and up 4. So negative 1 comma 4. Okay, there we go. So go ahead and copy this line in your notes, and I want us to find the slope of this line using two different methods. So here we go. One of the methods you should have learned in the past is, of course, M stands for slope. The formula is, write this down please, y over x minus x. Okay, now you should know in this ordered pair here, negative 1 is your x, 4 is your y, 2 is your x, 3 is your y. That's pretty simple. Okay, and so what we're going to do is we're going to substitute the y values in for y and the x values in for x. Now, listen to me. It does not matter which x value you put first in for x, but if you put the 2 in first for this x here, then you better put this 3 in first for the y up here. If you choose to put this x in here first for this x, then you better put this y here in first for this y here. Okay? All right, moving on. Now, having said that, let's go ahead and find the slope of this line. I'm going to go ahead and use this y over here first, so I'm going to put 4 minus 3. Okay? 4 minus 3, because my y here is 4 and my y here is 3, so 4 minus 3. Now for my x's, I'm going to put negative 1 minus 2. Negative 1 and then a 2. So my first x is negative 1 and then the minus sign here, right here, so minus and then 2. Now if you're weak with signed numbers, then use a calculator. Okay, 4 minus 3 is 1, and negative 1 minus 2 would be negative 3. So you should know by now that a positive number over a negative number, a positive divided by a negative makes the whole fraction negative, and 1 divided by 3, of course, is 1/3. Never write your slope as a decimal, leave it as a fraction, please. Okay, so m, your slope, is negative 1/3. That should look familiar from last year. Okay, y minus y over x minus x. Now that's one of the ways to find the slope of a line. Okay, another way to find the slope of a line is to use this formula right here. Rise over run. Okay, so write that down please, and hopefully your handwriting will be a lot better than mine. Rise over run. Now what you do is you take these 2 points that you just used and you connect them using vertical and horizontal lines. So you can either go straight down, there's a vertical line, and then straight over there's a horizontal line, and of course it makes a right triangle. Or if you want to do it this way, you can go straight over, that's totally fine, and then go down. Okay, either way is acceptable. So you connect your 2 points using vertical and horizontal lines. Now the next thing you do is you find the length of your vertical line. That's going to be your rise. And doesn't that make sense? I mean, rise means going up and down to get up. So rise going from this point here, let me change colors real quick. Rise going from this point here to this point here, the rise would be 1. You don't count where you put your pen. Okay, you start here and you go up 1. Don't count where you put your pen. You put your pen here and you go to 1 point. So the rise is going to be 1. Now let's count the run. So we're going to start at this point here and go over to this point here. Okay, so don't count where you put your pen. Put your pen here, but don't count. And then as you go over, you count each movement. So I'm going to start here. I'm going to go 1, 2, 3. I'm going to do that again. Put my pen here and I go 1, 2, 3. So the run is going to be 3. Now, there's one thing you must remember. Please make note of this in your notes somewhere. Whenever you use this formula here, students, you have to remember to check to see if your slope is going to be negative or positive. Now, listen to me. If the line is going down from left to right, it is a negative slope. If the line is going upward, like this green line is, from left to right, that would be a positive slope. Let me go over that again. From left to right, going downward, negative slope. From left to right, going upward, positive slope. Okay? So please don't forget to check that if you're using rise over run. And again, this should be reviewed hopefully from last year. So either formula that you use, y minus y over x minus x, or rise over run. Either way, you get negative 1/3 for your slope. Okay? Negative 1/3. Okay, moving on. Now, I want you to pause the video and I want you to try this problem on your own. I want you to find the slope of the line both ways. When everyone's done, the supervising teacher can turn it back on and you can check your answers. Okay, go ahead and find the slope using both methods and you should get the same answer. All right, go ahead and work on this now. Okay, hopefully everyone's done. And if not, then when the teacher needs to pause the video again, I'm going to go ahead and write these ordered pairs in. It looks like this pair here, this ordered pair here is over 1, 2, 3, 4, 5, and it's down 1, 2, 3, 4. So this ordered pair is 5, comma, negative 4. Now anything that you missed in your notes, fix. Maybe you got this ordered pair wrong. If you did, please fix it. This ordered pair here, 1, 2, 3, 4, 5 is over 7 and up 3. So 7, comma 3. Now, let's first of all find the slope using y minus y over x minus x. Okay, here we go. Well, here's my x, here's my y, here's my x, here's my y. So I'm going to use 3 for my first y, so it's going to be 3 minus negative 4. 3 minus negative 4. For my x's, it's going to be 7 minus 5. Here's my x up here, here's my x down here, 7 minus 5. Well, 3 minus a negative 4 is 7. Use a calculator if you need to. And 7 minus 5 is 2. This fraction here cannot be reduced, and so this is your slope. Very good. Hopefully you got that right. 7/2. Now let's use the formula, rise over run. I'm going to draw my triangle like this. I'm going to go over to here and then down to here. Okay, let's find our rise first. I'm going to start right here and count down. 1, 2, 3, 4, 5, 6, 7. So my rise is 7. I'm going to do that again starting down here. So I put my pin here. Don't count where you start. I'm going to go up 1, 2, 3, 4, 5, 6, 7. And then your run is going to be 1, 2. Or start here and go 1, 2. Now don't forget to check your sign. Going from left to right, is the line going up or going down? Will you go to the furthest point left and you go to the right, the line is going upward, so your slope would be positive. Okay? All right. If you didn't do well on this, ask questions and fix your notes and make sure you understand this, because you really should remember this. Excuse me. You really should remember this from Algebra 1 or 2, and you should be able to find the slope of a line in your homework tonight. Okay, that's really, really important. Let's quickly review the relationship between slopes and parallel perpendicular lines. These next two notes are amazingly important, so please write them down. Here we go. Write this down. Parallel lines will always have the exact same slope. Please write that down. Perpendicular lines will have opposite reciprocal slopes. Please write that down. Let me show you what I mean. If I told you the slope of one line, now watch this carefully, was 1/2, then if the line was right here and the parallel line looked like this, the slope of the parallel line would also be what? 1/2. Did you get that? Parallel lines will always have the same slope. So if these two lines are parallel and I know the slope of one line is 1/2, then I know the slope of the other line is also 1/2. Please write that down if you need to, okay? Now, let's come down here to perpendicular lines. Let's say I have two perpendicular lines like this. I know they're not perfectly drawn, but you get the idea. And let's say the slope, actually I want to turn those a little bit, so let me change that. Okay, here's two perpendicular lines. And let's say the slope of this line right here, I'm just making this up. Let's say the slope of this line is negative, and again, I'm just making this up, 3/4, okay? Well, if the slope of this line here is negative 3/4, then you know the slope of this line here is, now look, perpendicular lines have opposite. That means you change the sign. So if this sign is negative, then this sign here is positive. And then it says reciprocal. That means you flip this. So if you flip 3/4, you get 4/3. So do you see the relationship of the slopes of perpendicular lines? One slope will be positive and the other slope will be negative, and then whatever the slope is, the other slope will be flipped, or the reciprocal is what we call it. You need to understand that perpendicular lines have opposite reciprocal slopes. Now it's really important, students, as you understand this. So I hope this is making sense. Let's continue on. Now, with these last two comments in mind, please write down these three linear equations. Y equals 2x plus 4, y equals 1/2 x plus 2, y equals negative 2x plus 1. Please copy these down. Now, while you're copying these down, please listen to me. Remember, in algebra, whenever y is by itself, then the number with x is always your slope. Let me say that again. Do you remember from Algebra 1 and Algebra 2? Whenever y is by itself, the number next to x is the slope. So y is by itself here, y is isolated here, and y is isolated here. So in this equation here, please write this down. What number is next to the x? Or what is the coefficient of the x? 2. So your slope is 2. What is the coefficient of your x here? 1/2. So the slope of line number 2, or linear equation number 2, is 1/2. Now, what is the coefficient of x? Negative 2. So what is the slope of this linear equation? Negative 2. Now, here's my question for you. Let's see if any of these lines are parallel or perpendicular. We're going to call them line 1, line 2, and line 3, okay, for obvious reasons. All right, so here we go. Are any of these lines parallel? And here's what's so cool. You're telling me whether or not these lines are parallel, and you're not even looking at the lines. And you don't need to look at the lines. All that you need to do is look at the slopes of these lines. So parallel lines have the exact same slope. So what is the slope here? 2. Do any of these other lines have a slope of 2? No, they do not. Here's a slope of 1/2. Do any of these lines have a slope of 1/2? No. Here's a slope of negative 2. Do any of these other slopes have a slope of negative 2? No. So write this in your notes, please. None of lines parallel. And there's a symbol for parallel. All right. None of the lines are parallel. Now, let's see if any of these lines are perpendicular. Remember, their signs have to be different, and they have to be flipped, or the reciprocal. Well, look, we know for sure this line here and this line here, we know for sure they're not perpendicular. Well, Mr. Earhart, how do you know that? Because the slopes have to have different signs, and the sign of this slope is positive, and the sign of this slope is positive. So I know these two lines here cannot be perpendicular. However, maybe this line here and maybe this line here is perpendicular. Well, let's see. Is one positive and one negative? Yes. However, is one slope flipped when compared to the other slope? The answer is no. If you were to flip 2, remember 2 is really over 1. 2 is the same thing as 2 over 1. And if you flip 2 over 1, you get 1/2. So no, those two lines are not perpendicular. However, this line here is perpendicular to this line here. And here's how I know. This slope here is positive and this slope here is negative. And notice if you flip 1/2, you would get 2 over 1 or 2. Or you could say this, if you flip 2 over 1, you get 1/2. So I would write this somewhere in your notes. I would write lines. I would put line 1. I may as well be wrong all over, huh? Be consistent. Let's try this for the third time. Line 2 is perpendicular to line 3. I'm teaching you little symbols here. We're going to use this here. This means perpendicular. Okay, right here. This means perpendicular. All right. Line 2 is perpendicular to line 3. Got it? So you need to know this, guys. This is very important. You'll be tested on this. Parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. All right, let's continue on. Now, what if I didn't give you a linear equation? Let's look at a problem that doesn't have any equations. Are you ready? Please watch this carefully. Here we go. Copy this problem in your notes. I'm going to move on, so please copy it quickly. Copy it down. Point A is 1, 2. Point B is 4, 4. Point C is 3, -1. And point D is -3, -5. I want you to find the slopes of these 3 lines, okay? And then tell me if any of them are parallel or perpendicular. Now I'm going to do this quickly. I would really like you just to take notes and trust me on this, okay, to save time. So just copy this down. I'm going to find the slope of AB, the slope of AB. So here we go. Here's A and here's B. Are you ready? Y minus Y, that's 2 minus 4. X minus X, that's 1 minus 4. Do you see what I just did? I just used the formula Y minus Y over X minus X, okay? So I want you to find the slope of line AB. So Y minus Y, X over X, I'm going to get a -2 over a -3, and we should know by now a negative over a negative is a positive, and 2/3 cannot be reduced. Very good. Now let's find the slope of AC. So the slope of AC. Here we go. So using this point and this point here. All right, here we go. Y minus Y, that's 2 minus a -1. And then X minus X, 1 minus 3. And let's see what we get, okay? 2 minus a -1 is 3. And 1 minus 3 is -2. And a positive over a negative is negative. And 3 over 2 cannot be reduced. Now let's find the slope quickly of DC. So the slope of DC. All right, so here's D and here's C. Let's use those 2 points. So Y minus Y is -1 minus a -5. X minus X is 3 minus a -3. And what we get out of that is, and I hope I better stop and make sure I'm not making little mistakes here. Let's see. -1 minus a -5, that's correct. And then 3 minus a -3. Okay, so 1 minus a -5 would be 4. And 3 minus a -3 would be 6. Again, use a calculator if you're weak with your sign numbers. And what you should get out is 2/3. Okay, so let's see. We have, look at this. We want to know if any of these lines are parallel or perpendicular. Well, first of all, the slope of AB is 2/3. Do you see that? And the slope of DC is what? 2/3. They're the same. So I can write this down in your notes, please. I can write line AB is parallel to line DC because they have the same slope. Now look at this. I can also write this down, please. Line AB is perpendicular to line AC. Can I not? Sure I can, definitely. Because look at their slopes. AB is 2/3 and AC is -3/2. One is positive, one is negative, and 2/3 when it's flipped is 3/2. And look at this. I can also write segment AC or line AC is perpendicular to line DC. Can I not? Because look at your slopes. The slope of AC is -3/2 and the slope of DC is 2/3. One is negative, one is positive, and if I take 3/2 and flip it, I get 2/3. And so definitely I can make these 3 statements here just looking at the slope. I hope I've not gone too fast. We need to continue on, but you need to be very familiar with parallel and perpendicular lines and their slopes. Now let's quickly wrap up the video with some quick, easy definitions. Right quickly, and we're finally done. Here we go. Okay, collinear points. Those are points that lie on the same line. Collinear points, points that lie on the same line. Now listen to me. I'm going to give you a homework problem. 2 of these. I believe they're 19 and 21. I've not given you any problems like these, so you might struggle with these two on your homework. That's okay. That's what a track one class is all about, to challenge you, to make you think. And you know what? You've got a homework video to watch. So collinear points are points that lie on the same line. So if I say points A, B, and C are collinear, you know that means that they all lie on the same line. Okay? The same line. Coplanar points. Those are points that lie in the same plane. Okay? Of course, a plane is a flat surface like this. And we'll get more into that later. Okay? But if I have a point here, it's like a sheet of paper. And if I have three dots that are drawn on that sheet of paper, those 3 points all lie on the same plane. Okay? However, if I take a sheet of paper and I hold it right here, and then I take a marble, put some dots here, and I hold the marble up in the air, this marble is not lying in this plane right here. It's up in the air. Okay? So whenever I say that points are lying on the same plane, what I mean is they are called coplanar points. You need to know that. So points that are lying on the same line, if I have a line like this, and I've got a point here, and a point here, and a point here, and a point here, all of those points are called collinear points. If I have a bunch of points like this and they're all in the same plane, I call those points coplanar points. That's pretty easy to understand. Okay? All right. Now I want to talk about parallel planes and intersecting planes. Do the best you can to draw this in your notes. Here's like a sheet of paper hanging in the air, and then another sheet of paper down below it, and then this dotted line here is just kind of for effect, so you can see that they're not touching. So these 2 planes here are called parallel planes. I guess we'll call them plane number 1 and plane number 2. You know what, students? A really good example of parallel planes would be a bookshelf. A bookshelf, okay? So you have 2 shelves on a bookshelf. Those shelves are going to be parallel planes. You've got a shelf here and a shelf here. They're parallel, they're running the same direction, and they're both flat surfaces. Okay? And that would be a good example of parallel planes. Now, perpendicular planes. This is the last slide, and I'm finally done. Okay? Here's what I'm going to tell you what parallel planes are, and then I'm going to kind of ask you to use your imagination a little bit. Okay? If you can, I know a lot of you are not artists. I'm not either. Okay? But do the best you can to draw a shape that looks like this, and then a plane that's going to go down through. And I'm trying to think. What we're going to say is we're going to take a knife and pretend that we cut a little hole here in the plane, or like a sheet of paper, and then we're going to run this plane right through this plane like that. Okay? And those 2 planes are called intersecting planes. Now, let me describe it like this. Please listen to me carefully, students. Let's say that you took a sheet of paper and you took a pair of scissors and put a little slit in it, okay? And then you took a smaller sheet of paper and you ran that sheet of paper right through that slit, like that, okay? Would it not look like this? Sure it would. And those 2 planes are called intersecting planes because they're crossing, they're going through each other. Can I show you something? These 2 lines here are called intersecting lines. They're crossing right here at a what? What do we call that? A point. Got it? Okay. Now, these 2 planes are intersecting. But hold it. Look at their intersection. You need to know this. Their intersection is a what? It's a line. Do you see it right here? I would write that in your notes. When 2 planes intersect, their intersection is a line. When 2 planes intersect, their intersection is a line. You need to know that. Let me say it for the 3rd time. When 2 planes intersect, their intersection is a line. You can see it right here. I'm showing it for you, okay? It's like a little slit with a knife or a pair of scissors that you've made, and you run a piece of paper through that little slit right there. You have 2 intersecting planes, and their intersection is a line. Okay, been a pretty long video today, but it is a track 1 class. Be encouraged. You can do this, okay? Be sure and do the homework tonight. Be sure and ask questions on your homework. Be sure and watch the homework video to help you, okay? And call or email if you have any questions. You guys have a good day today.